Hi everyone, just a quick video to finish off the last question which Corrade sent me just before the weekend. Also, this is quite a nice one, and as soon as I looked at it, I thought I've got a memory of doing this in class. I think Ksenia showed it to me, and I've just got a really vivid memory of it because I'm sure I did 100 divided by 4 wrong, leading to the wrong answer. But also why I remember it is because there's a really complicated way of doing this on the website, which I really don't understand why they're doing it that way, because this shouldn't be worth 12 marks. As far as I'm concerned, this should be worth 7 or 6 or something like that. It's just not that much work. It really isn't. This is a typical consideration of energy question. Like that, this is what this is. Like, it's a dynamic question. Dynamic questions tend to involve, energy before and energy after, whereas the static questions in springs and strings tend to just involve F equals, balanced forces basically, and T equals lambda x over L. But yeah, this is a dynamic, and so we're going to use basically energy considerations. So what I'm going to do. Have a go at the question if you haven't already, but I'm just going to do a before and after, and I'm going to do some diagrams, yeah? So let's do some diagrams of what's going on here. Okay, before, essentially what we've got, in fact, it might be nice, let me just move the question down a little bit so we can see it, next to us here. Okay, right. Sorry, getting a bit slower on this. Okay, is that better? Or maybe I should have it beneath? I just don't know. Yeah, beneath works good. Okay, let's talk about what's going on before and what's going on after. Before, you've got a spring, not a string. That's the first thing to consider. It says what amused me actually is it says it's just hanging equilibrium. It tells you lambda. Let's write down lambda is 100 g. Yeah. Um, but you actually want to look at this bit. The particle is then pulled downwards, so AB is 2.15. Remember, the actual length is 2. So I'm going to draw this. I think it's always handy on these diagrams to show the natural length, 2, and then the extension, 0.15. Yeah? Okay, and that's what we've got going on before. So that's nice. Cool. Remember, it's 3 kilograms. Okay, after what's going on. Now, the one thing which is confusing in this is it's a spring, and so we need to consider compression. It's going to be going into compression when it comes to instantaneous rest, yeah? Now, when it's in compression, well, let's draw it like this. Let's point out that we're going to have, and I'm going to put something else on this diagram. You're going to have, x, where x is the degree to be, the length of the compression from the natural string to where it is. And oh, hang on, let me just take that away. And so if we've got x here, we're going to have 2 from there to there, yeah, because that's the natural length. It's nice to show this on the diagram. Now, what I'm also going to show on this side is the extra bit of 0.15, just because I'm going to make the GPE level 0 at this point here. Yeah, GPE equals it. Well, it's a bit ambiguous for my diagram because I've drawn the 3 kilograms on. Let me just put the dot on like that, but we'll just remember it's 3 kilograms. Should I do a bit of colour? Sorry, there we go. Splodge it on like that. Yeah. So yeah, I've put the 0.15 on there because I want this level, if we consider this level a GPE level of 0, then it will be easier to do this question. Okay, now we can just do it all of energy considerations, yeah? So before, what have we got? GPE is 0, KE is 0, and so EPE, elastic potential energy, well, that's just going to be lambda x squared over 2L, which is going to be 100G times by 0.15 squared over 2 times 2, which is 4, yeah? And you can do the whole question just with this little this little technique. So I don't know why it's worth 12. It should be worth 7. Okay, after. Right. GPE is not 0 anymore. It's going to be equal to, because we're going up. Oh, yeah, and sorry, my diagram is quite misleading there. Can I just draw it out more carefully? Yeah. So I'm saying it's being compressed by a distance x here. So that's where the splodge is, if you see what I mean. That's where the mass is. And so it's been compressed by a distance x. And so anyway, working out the GPE, we need to do m times g times height. Now that's 3g, because m is 3, times by the height. Well, height above GPE being 0 is 0.15 plus x. KE is going to be 0 because it's at instantaneous rest. When you're at instantaneous rest, the velocity is 0. That's always the case throughout mechanics. But we will have some elastic potential energy, and that's just going to be given by lambda x squared over 2L. So it's going to be 100g x squared over 2 times 2. Yeah. Okay, right. Now it's just a case of energy before equals energy after. So this is where I went wrong when I did it in class, quite embarrassingly. 100g divided by 4 is 25g, times by 0.15 squared. That should be equal to 0.45g plus 3gx plus 25gx squared. Okay, right. And now it's just a case of solving this quadratic, and I just did it on my calculator, yeah? And it gives you a lovely answer on your calculator, but essentially you're solving 0 equals, okay, that's your coefficient on x squared, here's your coefficient on x, and then you've just got a bunch of junk at the end, which I think comes to quite a nice number if memory serves, but I can't be bothered to work out the values now. No, just plug it all into your calculator, and I think you get x is minus 0.15 or x is positive 0.03. Yeah. Now this makes loads of sense. Yeah. When is it at rest? Well, it's at rest, like just before you release, if you like. Well, it's going to bounce down. When it goes bouncing down, it's going to be turning around there at the GP equals 0 level. But when it's bouncing up, it's going to be at positive 0.03 above, the natural length of 2. Yeah. So that's going to be 0.03, and hence, as this is A and this is B, yeah, the length of AB is actually 1.97 meters. Yeah, I'm really confused as to why, because I mean I've got loads of time for the madasmaths website. I really have. That's why I put you onto it. I think it's good. I think it's good. It's got loads and loads of really good questions, but just occasionally you see them do the answer, and you think, why have you done it like that? You're doing it the hard way. I guess, same thing happens on Solution Bank, and whenever you look at somebody else's answers, sometimes it's a bit of a head scratcher why they seem to have chosen an indirect route to the answer. But yeah, x is AB's length is 1.97 meters there. Hope that makes sense. Keep up the hard work, and yeah, find me some more tricky spring questions because I quite like doing them. Bye bye.